Hello, and welcome to our review for the circuits test. So, this test as a whole is somewhat short in that we haven't really covered all that much information going into this test. It really just kind of boils down to dealing with the two types of circuits. You're dealing with series circuits and parallel circuits. As a quick, short little review over this, okay, we have a series circuit which looks something like this. Got a battery hooked up to one resistor, and a second resistor, and let's do a third resistor like this. Okay, this is a series circuit. There's only one path for the electricity to follow. It has to go through every single resistor in order, starting at the battery, around through resistor 1 through resistor 2 into resistor 3. It has to hit all of them. That's a series circuit. A parallel circuit would look something like this, where we have something that looks like this. We'll do 3. Okay. We still have 3 resistors, but these are now in parallel. There's multiple paths for the current to take. Okay. We can have the current going in a loop like this around here. It can go in a loop like this around there, or it can go in a loop all the way around through resistor 3. There's multiple separate pathways for that to go. Okay, it's important to remember how to distinguish between these two types of circuits. There's a couple of general rules you need to keep in mind when we're dealing with these circuits. In short, it's how the different parts of Ohm's law, which is V equals IR, how do each of these variables change depending on the circuit? As an example, in a series circuit, if we are looking for the current, okay, in a series circuit, if you know the current anywhere, if I know that the current here, we'll say I3, the current through this resistor, okay, if I know this is 2 amps, everywhere else in the circuit, it doesn't matter where I check. If I suddenly ask, hey, what's the current right here? In a series circuit, it's the same everywhere. If I know it's 2 here, it's also going to have to be 2 here. Okay? If I check over here, it's also going to be 2 here. It's going to be 2 amps no matter where you look. In a series circuit, it is the same everywhere. Parallel circuit, it's going to be different everywhere. Because when we have this current flowing through a wire, like right here, when we get to a junction, that current is going to split. Some of it's going to go this way, some of it's going to go that way. It's going to split again here, okay? Every time you get to a junction in a parallel circuit, the current splits. It's not an even split, but the point is you're going to have different currents for each of the branches. In a series circuit, it's the same. In a parallel circuit, it's different. Obviously, there are also rules for voltage and for resistance. I would refer back to the slides if you have questions about those. I will talk about them as they come up. All right, there's my quick little crash course review in the two types of circuits. Let's get into some practice examples now. All right, so we're going to start off with number 1 on the review, a couple of basics ones first before we look at the full circuits. So, what voltage is applied to a 4.09 ohm resistor if we know that the current is 2.28 amps? So we are dealing with voltage, current, and resistance. That means we're going to be dealing with V equals IR. Or on the formula sheet, okay, this is Ohm's law. It's also on the formula sheet. It's right here. It's called current on here, but it's the same thing. It's just been rearranged to solve for current instead of voltage. Okay, but that's Ohm's law. So we're looking for voltage, so I'm going to use this version of it. So we're just going to plug everything in. Okay, so V equals my current, which is 2.28 amps, and my resistance, which is 4.09 ohms. Okay, get those there, and then it's just a matter of plugging them into the calculator. 2.28 times 4.09, and there is my voltage. Or my voltage. Okay, V equals about 9.3 2. Okay, it's rounded a little bit different, but that's fine. Alright, that's Ohm's law. That's all there really is to it. You just have to keep in mind to keep things straight. Okay? Alright, here's another example. We have a 6 watt lamp drawing 0.710 amps. What is the lamp's resistance? So, for the most part, most of the things we've dealt with have been questions like Ohm's law. Okay, one is Ohm's law, this is Ohm's law, this is Ohm's law. The difference is we are dealing with watts. Okay, we talked about watts before. Watts is a unit of power. In this case, it is electrical power. There are formulas here on the formula sheet for this. Okay, they are right here. Electrical power. Now, we've dealt with these types of equations before where we have a bunch of things that are equivalent. As a little refresher, I'm gonna write this here. P equals IV, which is equal to I squared R, which is equal to V squared over R. Okay, this is the whole big equation. You do not use the whole thing. You do not use the whole equation. You pick the 2 parts you need and you set them equal. That depends on what you are given, okay? So, I am given 60 watts. That's power. That means I'm going to need this part, okay? I'm also given current, and I'm looking for resistance, so I'm going to have to pick something with current and resistance in it. That's this one. I'm going to pick these 2 parts and make them be equal, because if everything is equivalent, I can just pick the 2 parts I need and set them to be equal. So P equals I squared times resistance, and then I can plug everything in. 60 watts is equal to my 0.71 amps squared times my resistance. Divide this over to the other side, and I'll get my answer. So 60 divided by 0.71 squared gives me my answer of a resistance of 119 ohms-ish of resistance. Really, the only thing you have to remember dealing with the power equations anytime you're dealing with wattage is you need to pick the 2 parts of the equation, okay? Sometimes it's going to be P equals IV. Sometimes it's P equals V squared over R. Sometimes it's P equals I squared times R. It just depends, okay? All right. So in general, for these short questions, Ohm's law is very straightforward. Power is very straightforward, okay? It's these types of questions where we're starting to deal with circuits that we need to start thinking about the rules for the different circuits. How does it work in a series circuit? How does it work in a parallel circuit? So I'm going to go through one of each, and then we'll do the bigger ones on the back. All right, we're going to do number 6 next. So we have 2 resistors, 4 and 7 ohms, connected in series across a 9-volt battery. We want to find the equivalent resistance of the circuit, and then we want to go on and find the current through the 4 ohm, the current through the 7 ohm, and then the voltage drop across each resistor. That's a bunch of things, so I'm going to try to keep this segmented, okay? So, part A. We want to find the equivalent resistance, okay? Anytime we talk about equivalent resistance, so I'm going to write this here. Equivalent resistance just means total. Okay? Find the total resistance. Okay? So we are dealing with a circuit that is in series. So if I want to find a series total, all I have to do is add them up. Okay? So to find that total resistance, RT, it's going to equal R1 plus R2, which in this case is just going to be 7 plus 4, which is going to give us a total of 11. So 7 ohms plus 4 ohms equals a total of 11 ohms. There's part A done. Okay? That's why you got to remember what type of circuit is which, because that's going to change depending on the situation. All right, part B. We now want to find the current through the 4 ohm resistor. Okay? So anytime you're looking for a specific part of a circuit, V, I, or R, you're pretty much going to be using Ohm's law. The catch to using Ohm's law is that you need to keep in mind, how am I applying this? Am I applying it to the entire circuit, or am I just applying it to a specific component? If you're doing it to the whole circuit, that means you're using totals. That would give you voltage total equals current total times resistance total, okay, for the whole circuit. If we're doing it for a specific resistor, we're going to have to do it for that resistor, okay? So let's say we want to know the current through the 4 ohm resistor. That would be the voltage across the 4 ohm resistor, the current across the 4 ohm resistor, and then the resistance of the 4 ohm resistor. Applying it specifically to one component versus the entire thing, okay? That said, because it's a series circuit, there's a shortcut we can take. One of the things we talked about at the beginning was that if you're looking for current in a series circuit, if you know it anywhere in the entire circuit, you know it everywhere in the circuit. Phrased another way, if you know that the total resistance, then that's the, sorry, not total resistance. If you know the total current in a series circuit, that's going to be the same everywhere. Okay? The current has to be the same in a series circuit. So if I wanted to find it specifically through the 4 ohm resistor, I would need to know the voltage across the 4 ohm resistor. And I don't know that. I only know the total. But I know the total voltage, I know the total resistance, I can solve for the total current, which means it's going to be the same everywhere else. So that's what I'm going to do. Okay, I'm going to use V total to get I total to get resistance total. Okay, so my total voltage was 9 volts. That's going to give me my current here times my total resistance, which was 11 ohms. Okay, I'm using my totals to get the current, so I'm just going to do a little calculation here of 9 divided by 11, and my total current, okay, IT is going to equal 0.81, okay, 818, we'll say. Because this is a series circuit, it's the same everywhere. So when it's asking what is the current through the 4 ohm resistor, it's this, okay? So the current through the 4 ohm resistor is also going to be 0.818, okay? It is the same everywhere. It's also going to be the same for part C, okay? Part C wants us to find the current through the 7 ohm resistor. It's the same thing, okay? Everywhere in a series circuit has the same current. It has to have the same current. So current through 7 ohm, it's also going to be the same. Alright, lastly, what is the voltage drop across each resistor? Okay, this is where we start applying Ohm's law specifically. Anytime we're finding the voltage, we're finding out how much energy it takes to go across that component. Every time you cross over something, you lose a little bit of voltage. So we want to apply it for each individual resistor. So the voltage across the 4 ohm resistor would be the current across the 4 ohm resistor, which is going to be 0.818 because it's the same everywhere, times the resistance of the 4 ohm resistor, which is 4 ohms, and we're going to do the same thing for the 7 ohm resistor. But instead of using the current through the 4, we're going to use the current through the 7 and the resistance of the 7 ohm resistor instead. Okay, now it's just a matter of calculating these, and when we multiply these together, we find that there is a 3.3 volt drop across the 4 ohm resistor, and across the 7 ohm resistor we have a 5.7, that should be volts. Okay, a 5.7 volt drop there. Okay. Alright, a lot of this just boils down to understanding, how do we apply Ohm's law? Are we applying it for a specific resistor? Are we applying it for the entire circuit? What are we looking for? That's really the only thing you have to keep in mind. The actual calculations, that's not the hard part. The hard part is remembering the different rules for the different circuits. So I would really try to focus on that. Okay? Alright, but that was it for the series circuit. The parallel circuit's going to work the same exact way, but you're just going to use parallel rules. So I'm going to talk through this one a little bit faster. Okay? So we have two resistances, 18 and 63. They are connected in parallel. The resistors are also connected to a 9-volt battery. What is the equivalent resistance of the combination? And then what is the current through each of them? Okay. So equivalent resistance for a parallel circuit. This is the funky one that looks like this. 1 over the total resistance equals 1 over R1 plus 1 over R2 plus however many there's going to be. Okay. The thing you have to keep in mind when you are adding them in parallel is you need to add your resistors together. You need to add their inverses. So instead of 18, we're going to do 1 over 18. And we're going to do that plus 1 over 63. Okay? Instead of just doing 18 plus 63, we're doing 1 over 18 plus 1 over 63. And that's going to give us, let me just punch this into my calculator real quick. So 1 over 18 plus 1 over 63. Okay, if you do it like this, it's going to give me an answer of 0.0714. So 0.0714, and that's going to equal 1 over my total. Okay. The thing you have to keep in mind is at the very end, you need to flip your answer. Okay. So let me just turn this into a fraction real quick. Okay. My answer is 0.0714 over 1. I need to flip both sides upside down. So, instead of doing this, I'm going to do 1 over 0.0714 equals my total over 1. I flipped it upside down. Now I'm going to get my total. Okay? So, let me just do that real quick. 1 divided by 0.0714 like this, okay? And that is my total resistance, 14, okay? RT equals 14. All right, that's really the part that most people mess up on when we're dealing with parallel circuits. It's the inverse section, okay? All right, so that part is done. Then we want to find the current through each resistor. We're just going to apply Ohm's law for those specific resistors. The only thing you have to keep in mind is that when we are dealing with a parallel circuit like this, okay, every single branch is going to get the same amount of voltage as whatever's before the parallel section is, okay? So I'm going to draw another circle here, a very dark one, V equals question mark, okay? Whatever the voltage is here, that's how much every single branch is going to get. How do we know what the voltage is here? Well, we just need to check, is there anything in front of it? Well, just the battery, okay? The battery is hooked up directly to this, which means every single branch in this circuit is going to get the voltage of the battery. It's the same deal for this one, so that's what we're going to do. Every single branch will get the full 9 volts. So, same deal, okay? So, the 9 volts across the 4 ohm resistor, or the 18, okay, resistor is going to equal the current across the 18 ohm resistor times the 18 ohm resistor itself, okay? So we're going to do 9 divided by 18. That's going to give us a current across the 18 of 0.5 amps, okay? Then we're just going to do the same thing for the other one. 9 volts equals the current across the 63 times the 63 ohms. And then we're just going to do 9 divided by 63. The current through the 63 ohm resistor is going to be 0.14 amps. Alright, so that pretty much covers everything that's going to be on the test. If I'm being honest, that's pretty much everything, okay? There's maybe a couple other things that are from the practice, like converting electrons into charge, but we've already done that a bunch, okay? The only other thing that's going to be on there, okay, that y'all are going to be concerned about probably are these type questions, where you're missing a bunch of information, okay? These are the ones we did on the quiz, not the exact ones, but the idea is the same, okay? So I'm going to go ahead and try to get through these. Alright, so we're going to start with the number 12, okay? We have here a series circuit. That means I'm going to be dealing with series circuit rules, okay? So here's what that's going to look like. I need to figure out where to start, okay? On the test, this is going to be in separate parts, okay? I will give you an order to go through them in, okay? As with all multi-part questions, you should probably do them in order, okay? I'll try to help y'all out by doing that, okay? But how do you figure out where to start? Generally, where you want to start is you want to find totals first. You want to find the total voltage, the total current, the total resistance. Total resistance, RT, is probably the easiest place to start, okay? If I want to find the total resistance in a series circuit, I just need to add these together. 10 plus 8 plus 2, well, that's going to give me 20 ohms. There we go, one of them is done, okay? I have a total of 20 ohms. Alright, well, what's next? I should probably try to find total current next. Current's another easy one to find. How do I find total current? Well, I know the total resistance, but I don't know the total voltage, okay? VAB generally equals battery. I don't know what that is, so I can't find total current like that. I'm going to have to find it a different way. This is where it's really important to remember the rules for each circuit. In this case, this is a series circuit. The current is the same everywhere. If I can find the current somewhere else, I know what the total is because it's the same everywhere. So I'm going to need to find a voltage somewhere that I know. And I know this voltage, VAD. That's the voltage from A to D, okay? Or, in this case, the voltage across the 2 ohm resistor. So I know the voltage for this resistor, I know the resistance for this resistor, I can then calculate the current for this resistor, okay, by using V equals IR. Or in this case, I equals V over R. Okay? I can take the voltage for this resistor, divide it by the resistance of that resistor, and that'll give me the current. In this case, the current for the whole circuit because it's the same. So, what is the voltage for the 2 ohm resistor, VAD? Well, it's 20. So I'm going to do 20 divided by 2. Well, that's just going to be 10. Okay, I'm going to have 10 amps of current going through this resistor. That means it's going to be the same in the whole resistor. Because, again, it is a series circuit. It is the same everywhere. Alright, well, now that I know the amperage for this circuit, I can calculate the voltage of the battery. Okay, total current times total resistance. That's going to be a voltage of 200 volts. That's pretty big. Okay, but now I know that. Now I can go through and find my individual voltages. Alright, voltage for DC. That's going to be the voltage across from D to C, or from C to D, doesn't matter. Okay, that's the voltage across the 8 ohm resistor. So I'm going to, again, just use V equals IR, current through the resistor times the resistance of the resistor. So that's going to be 10 times 8. Well, that's 80. Same with this one. Okay, voltage from C to B, that's this one. That's across the 10 ohm resistor. So I'm just going to do, again, V equals IR, current times resistance. So 10 times 10 gives me 100 volts. Okay, I can check this now to make sure I'm right. In a series circuit, all of your voltage drops, so everything except the battery should add up to equal the battery. So if I do VAD plus VDC plus VCB, or 20 plus 80, that's 100, plus 100, that's 200, that should equal my battery, and it does. So I know that we are good, we are correct. Alright, that is the series circuit, okay? Now I'm going to quickly go through the parallel, right? Alright, same deal with the parallel circuit, but we're going to apply parallel rules. Okay? Again, you generally want to start with the total resistance. Okay? So that's what I'm going to do. And we're going to do it with parallel rules. So 1 over total resistance equals 1 over 6 plus 1 over 3. Okay? Add these together in a calculator because I am terrible at mental math. 1 over 6 plus 1 over 3 gives us 0.5. And then remember, I have to flip my final answer. So instead of 0.5, I'm going to do 1 divided by 0.5, which will give me my total resistance. RT equals 2 ohms. Okay. A quick side note, just to kind of show something off. Instead of doing the 1 divided by 0.5, if I had instead just hit this button right here, x to the -1 right here, if I hit that and then hit enter, oh, it also gives me 2. Okay. Raising something to the -1 power is the same thing as flipping the fraction upside down. This is usually a faster way to flip your fractions, just as an FYI. But if you have a method that works for you, do that. Alright, so that is done. We have that. Now we can go ahead and, well, we know I2. Okay, if I want to find the total, alright, this one's a little bit tricky. Alright, if I want to find the total current, that's going to be harder to do. In a parallel circuit, the current's not the same everywhere, okay? I1, this is the total current. This is the current coming out of the battery. That's going to split off into I2 and I3. Alright, and I don't know the voltage of the battery. I don't know VAB. So I need to try and find a way to find VAB. So this is again really helpful to know the rules for a circuit. In a parallel circuit, going back to this one again, okay, every branch is going to get the same amount of voltage as whatever is before that branch. In this case, again, there's nothing in the way. This is a straight parallel circuit. So the voltage for both of these branches is going to be the same as whatever the voltage right here is. Okay? And in this case, this voltage is going to be equal to the battery. So if I can solve for either of these voltages, I can find the total voltage of the battery. Okay? So what do I know? Well, I know I2 is 2 amps. Okay? That's this one. I know the current through here. Okay? Well, if I know the current through a resistor and I know the resistance, I can just use V equals IR to find the voltage for this resistor. If I know the voltage for this resistor, well, then I know what the voltage across this is, which is going to be the same as the battery. Okay? So that's real easy. 2 times 6 to find the voltage here. That's going to give me a total of 12. Okay? That means the voltage of the battery is 12 volts. Alright, now that I know the voltage of the battery, I can go ahead and find everything else I need. Okay? So if I wanted to find the total current, let's say, that would be, again, using my Ohm's law, V equals IR, or the I is V over R. Okay? I'll use this one. Okay? So the current for the whole circuit, I1, is going to be the total voltage, which is 12, divided by the total resistance, which is 2, which means my total current is going to be 6 amps. Now I can do the same thing over here to find I3, or I can do it a different way. Okay? So we'll do it the regular way first. Okay? I want to find the current through here, so I'm going to do I is V over R. Voltage for this branch, it's the same as the battery because it's a parallel circuit. So 12 divided by 3, that's going to give me a total of 4 amps. Okay? Now in a parallel circuit, my currents should add up to be the total. Okay? Whatever goes in has to come out. So I2 plus I3 should give me I1. 4 plus 2 is 6, which is what my total is. There we go, we're good. Okay? Alternatively, instead of doing Ohm's law to find this current, I could have just done the total 6 minus this one, 2, to get 4. That also works. Alright, so this is the first part of the review. I'm not going to have time to cover a combination circuit right now. I will get a combination circuit video put up during my third period class today. So if you're watching this in one of my first two periods today, it'll be up later. If this is in the future, then this is irrelevant. See the other video, which will be linked in the description, if that video is now live. Okay? Alright, good luck to y'all on the test. It's not as much as it seems like. You just really need to keep in mind the rules for the circuit. Okay? Alright, good luck.